In 12.4, we're going to talk about rational exponents. Now, I know you know what exponents means, but do you know what rational exponents means? Well, it's all about the base of this word, rational. So if you look at this, the base is ratio, okay? Ratio just means fraction. So what it means in common terms, it's fractional exponents. So here's what it's going to look like. If you have a base and a fraction up here in the exponent, the bottom number is the index, okay? It's the kind of root you're going to have, and the top exponent in that fraction is what's underneath the radical with it. So we're going to walk through these, and I'm going to show you how this works. And the first section, though, is just simplifying it. You're going to turn them into radicals and clean them up. That's all you have to do in this first section, and same way on your assignment. We're just going to get warm up with the easy stuff, right? So let's rewrite this. 7 to the 1/2 power is, this is the root, the bottom number is the root, and 7 goes underneath it. You could put 7 to the 1 power if you want, but really it's just the square root of 7. So I just want you to see, where do those numbers go? The 2 comes on the outside, and that 1 goes on the inside. Let's look at number 2. Okay, this is a cube, 64 to the 1/3 power. So I put 64 underneath with the root or the index of 3. Now I want to clean this up. So let's think about this. 64 is 8 times 8, isn't it? And if you remember, back in the day, we decided 2 times 2 times 2 is 8. And we have this twice, right? With 2 8s. So that means I can take 2 2s out. So that means I have a 4. It simplifies all the way down to a 4. Number 3, it says 5 to the 1/2 power. Well, that's the square root of 5 times the square root of 5, which hopefully you know the patterns by now. It just comes out to be a nice even 5. Look at 4. It's the cube root of 10 times the cube root 1/3 power of 100. Now, if we simplify this, we get the cube root of 10 times 100, but isn't 100 10 times 10? So there's 3 10s in there, so I can simplify that to just a simple 10. Number 5, here is the fractional power of 1/2. That means it's the square root of 2 times the square root of 18. Well, it's going to be the square root of 2 times 18, but let's factor this down. Isn't that 2 times 9? So there's 2 2s that can come out, and a 9 can pop out as a 3, right? Because the square root of 9 is 3. So it's really 2 times 3, so my answer is just a 6. So that's how we convert the rational exponents to square roots like we're used to. All right, in the second section here, we're going to convert to radical form. So we're going to leave things with the radical in them. And of course, we always want to simplify. So x to the 3/5 power. So I know I'm going to have an x. That 5 is the kind of root. Think of it as the roots go under the tree, so the 5 is underneath. It's the kind of roots, the 5th root, and that 3 goes underneath with it. There's nothing I can do to simplify that because there's only 3 x's under there. So I have to leave my answer just like that. Let's look at number 2. So I have a square root, you don't have to write the 2, but you can, of x cubed. Now, that does simplify. Remember, that's x squared times x, so I can pop an x out, right? Now, if I take an x out, I leave an x underneath. But remember the old rule that we said if we take an odd number out of an even index, we have to put absolute value bars around that. So in this case, we do need those absolute value bars. So maybe you need to write yourself a little note. Remind yourself. When an odd amount pops out of an even index. Remember, index is this little number right here. In this case, it was a 2. We don't really write the 2 because it's the understood one. But if it's an even index and we pop an odd amount out, we have to put absolute values around our answer. All right, so that's going to be important moving forward. Let's look at number 3. The fourth root of 3x. Now, there's nothing to the fourth power or anything under there that I can reduce, so that's as far as I can take it. Number 4 has a negative exponent, so the first thing I want to do is move it down to make it positive. So I'm going to put 1 over x to the 1/5. Then I write it as a radical, the fifth root of x. Remember, you can't leave a radical in the denominator. That's a big no-no, so we have to rationalize it. And we said to rationalize it, we have to multiply it by a funny-looking 1, something that's going to make that denominator turn into anything but a radical. So it's to the fifth root, so I need something to the fifth power in there, right? Well, I only have 1x, so I need 4 more for that to happen. And it's a funny-looking 1, meaning the top and the bottom have to match, okay? This has to equal 1, and this is what we call rationalizing. We always have to rationalize. And why? You can't have a radical in the denominator. All right, so how does this clean up then? Well, when I multiply this out, I have the fifth root of x to the 4th over, when I multiply these two, I'll have fifth root of x to the 5th, which means I can take that x out. It's no longer underneath the root, and it's just going to be x. It's going to look just like that. Number 5, x to the 1.4 power. Okay, this is weird, right? We need to be able to write this as a fraction. So how do we write this as a fraction? Well, let me talk you through this. So 1.4, if you talk about it, if you state it the way it's read, it's 1 4/10, right? So 1 4/10. Now let's make this an improper fraction. So 1 times 10 is 10, plus 4 is 14/10. So we're getting somewhere, but we still need to reduce, and that reduces to 7/5. So this is saying x to the 7/5 power. Now, how do I write that as a rational root? Well, there it is. There's my x. The bottom number is the index, the 5, and the top number goes underneath the radical. So it's the fifth root of x to the 7th power. Now, we're not done, because if there's 7 underneath here, that means I can take 5 out, right? So I can take 1x out. That leaves 2x's, x squared underneath. Now, I don't have to put absolute value bars on this because it's an odd index. I took an odd number out of an odd index, so I don't need the absolute value bars. I can leave it just like this. So make sure you simplify all the way. Now let's look at this last type of question. You're going to convert to exponential form. So your answers are all going to have exponents in them. So we're kind of going in the reverse direction. So let's rewrite each of these with a rational exponent. So 5, remember that 2 right here it comes out, so it's going to be 5 to the 1/2 power. That 2, this is the 1/3 power, so it's 2 to the 1/3 power. This right here goes underneath right here, so it'll be x to the 3/4 power. Now on this one, you want to be careful because there's a root here, right? It's the square root. We don't write that. It's understood. But it applies to the 3 and it applies to that x. So let's separate them out. 3 to the 1/2 power times x to the 3/2 power. All right? Remember, there's a 1 right there. We just don't bother writing it, but it is there. Okay? So we're going to leave my answer just like this. Look at 5. There's a little bit of work to do on 5. So the first thing we want to do on 5 is clean this stuff up, okay? So let's rewrite that first. So we'll have 4 to the 1/3 power times x to the 1/3 power, all raised to the 6th power. Now, remember when we raise a power to the power, we multiply powers? So now I'm going to have 4, 1/3 times 6 is 6/3, and then x is going to be 6/3. Let's keep cleaning it up. So I'll have 4 squared times x squared. Now, resist the urge to say 16x squared. I know you want to, but there will be times when you want to leave them in exponential form, and that's in future classes, but just be aware. Right now, I want you just to leave it in exponential form. Let's try this very last one. Okay, like before, we're going to take care of inside. So let's distribute this squared part first. So it's going to be 8 squared times x squared, right? Now we need to take that root and make it a rational exponent. So it's going to be 8 2/5 power and x to the 2/5 power. All right, that's what my answer will look like. All of them have an exponent. If you notice, on every one of these, each piece has its own exponent. Okay, and you want to always make sure to reduce it. Always reduce those exponents, okay? I hope this makes sense, and on your assignment today, you're going to see it kind of gradually get more complex, kind of like we did in the notes. But refer to your notes and let me know what questions you have.